Hi everyone. In this series of videos we're going to look at the solutions to the 2024 HSC Maths Advanced exam. We're going to start with the multiple choice questions. 1. Consider the function shown. Which of the following could be the equation of this function? So of course we're looking to model this with y equals mx plus c, where m is the gradient and c is the y-intercept. And we can see that the y-intercept is positive, so that's going to knock out b and d. And the difference between c and a is the gradient. With a, the gradient is positive, so it goes up from left to right, and with c, the gradient is negative, goes down from left to right. And we can see that this line goes down, so our answer is C. Question 2. In a group of 60 students, 38 play basketball, 35 play hockey, and 5 play neither basketball nor hockey. All right, easiest way to do this is to add up the 38, the 35, and the 5 and see how much in excess of 60 we are, because that's going to be the overlap in here. So that's 18, 78, and 78 take away 60 is 18. So there's 18 students in here, and they're the students that play both basketball and hockey. The answer is B. Question 3. Peers' marks in Year 10 assessments are shown. The scores for each subject were normally distributed. In which subject did Pia perform best in comparison with the rest of Year 10? So we want to work out the Z-score. And our formula from our formula sheet is the score, take away the mean, divided by the standard deviation. So let's work that out for English. So for English, we're going to have 78, take away 66, divided by 6. Just let me grab my calculator. And we have 78 take 66 divided by 6. It's 2. Wow, that one's pretty high, actually. I'm going to do a quick look down through here and see whether any of them are below the mean, but none of them are. So we have to work them all out. All right, let's work out maths. We have got the score, take away the mean, divided by the standard deviation. So 80 take 71 divided by 10. 0.9, so English is winning so far. For science, we have got 77 take 70 divided by 15. That one's not going to win, is it? Work it out anyway. Divided by 15. That's because of the large standard deviation there. 0.47. And then finally, history, that's a Z, is equal to 85 take 72 divided 9. 85 take away 72 divided by 9 is 1.4. Okay, none of those have a Z-score as large as English, and so English is our answer. Question 4. The parabola y equals x minus 3 all squared minus 2 is reflected about the y-axis. This is then reflected about the x-axis. What is the equation of the resulting parabola? You can do this through algebra, or you can do it graphically. It's probably a good idea to look at both of them. So let's have a quick sketch of this. Here we have got a turning point at 3, negative 2. And we've got a positive parabola, so it looks something like this. Not sure where it's going to cut the x-axis on this side. That's reflected about the y-axis, so it'll end up looking like this. And that'll bring it here to negative 3. And then it is reflected in the x-axis, which is going to turn it upside down like that. Now, if you want to just do this graphically, which is actually easier, that's going to have a graph of, we've got negative because it's upside down, x plus 3 all squared, and which one am I doing here? Plus 2, which is C. But let's have a look at it algebraically as well. If we are reflecting about the y-axis, then instead of x, we're going to put negative x. which gives us, I can actually factorise that negative out. And when I square a negative 1, square a negative 1, I get positive 1. So it's equal to x plus 3 all squared minus 2. Let me just rub that out. Now, that's only the first one. When we reflect about the x-axis, we're going to negate all of this. And so y will become negative x plus 3 all squared minus 2, which is negative x plus 3 all squared plus 2. So again, the answer is C. Question 5, what is the integral of 6x plus 1 all cubed dx? Right, so we've got a reverse chain rule here. I'm going to ignore all of this, and I'm going to go 6x plus 1, raise the power by 4, divide by 4, and then I'm also going to divide by the derivative of the inside function, which is 6, plus c gives me 1 on 24, 6x plus 1 to the power of 4 plus c, and that is A. Question 6. What is the domain of the function f of x is equal to 1 divided by the square root of x squared minus 1? Now when we're looking at domain, we're concerned with two things, a negative under a square root and a denominator of 0. And we could have both of these things occurring. So let's start with this because it's nice and easy. We don't want x squared minus 1 to equal 0. So that means that x squared cannot equal 1, x cannot equal plus or minus 1. But that's the easy bit. Now let's look at this. We want x squared minus 1 to be greater than 0. Now the easiest way to do this is to factorise and then draw a diagram. The critical points here are when these two brackets equal 0. So 1 and negative 1. And now we're going to test some points. I always start by testing 0, and I'm going to come back into this equation here, or inequation, to look at this. So put 0 in here. 0 squared is 0. Take away 1 is negative 1. Is negative 1 greater than 0? No, it's not. Let's test negative 2. Putting negative 2 in here. Negative 2 all squared is 4. 4 take away 1 is 3. Is 3 greater than 0? Yes, it is. And if we test 2 up here, we're going to get exactly the same answer. 2 squared is 4, take away 1 is 3. Is 3 greater than 0? Yes, it is. So our answer is going to be x is less than negative 1 and or x is greater than 1. Now, it is going to be, to write it in interval notation, it's going to be D, isn't it? Because it's everywhere from negative infinity up to and not including negative 1, union everywhere from 1, but not including 1, up to infinity. Question 7, the diagram shows the graph of y is equal to f of x. Which of the following best represents the graph y equals f of 2x minus 1? Okay, so we've got y is equal to f of 2x minus 1. I like to factorise this. It just helps. So we've got two horizontal translations here. We've got a dilation of 2, so that's going to make it, that's going to squish it together, push it together. And we've also got a horizontal translation, and it's going a half a unit to the right. Okay, so let's see if we can knock a few out. Look, it's not A, is it? Because that's going to the left. That's shifted over to the left. Yep, it's not A. B, that's shifted over 2 units to the left. I don't think it's that one either. C and D are both possible. Okay, so we can see that they've both been squished up, so the 2 is no use to us. We need to know which one of these has been shifted over a half. Oh yeah, it's C, isn't it? Can you see how that's been shifted a half? Whereas this one's been shifted 1 unit along. That's why I like to factorize it, because you can actually see how far it's been moved without these two getting in the way. So our answer is C. Question 8. Some data are used to create a box plot shown. Histogram is created from the same set of data. Which of these histograms is not possible for the given box plot? All right, this is to do with the shape of the distribution and the fact that you got to remember that there's a quarter of the data points here in that lower quartile. There's a quarter of them here, there's a quarter of them here, and there's a quarter of them here. Now that happens to be in each of these diagrams 16 data points. So that means, if I just put that here, we've got 4 data points here, 4, 4, and 4. Can you see that these ones must be more spread out than these two tails here, or the lower quartile and the upper quartile? They're all bunched together. That means it can't be D. Does that make sense? Because there's less. All the bunching here is in the middle, and there's less on the edges. If we have a look at A, it's fairly uniform. B, we have got bunching on the outsides and less in the middle. And here we have the same thing, don't we? We've got bunching on the outsides and less in the middle. So our answer is D. Question 9. A bag contains 2 red and 3 white marbles. Javan randomly selects 2 marbles at the same time from this bag. The probability tree shows the probabilities for each of the outcomes. So we've got non-replacement. Given that one of the marbles that Javan has selected is red, what is the probability that the other marble he has selected is also red? Now my initial thought was, well, it's a quarter, isn't it? Because these are all conditional probabilities. But then my next thought was, this is question 9. That's way too easy. So it's not a quarter, but I'll tell you why it isn't. This one here is the probability that given the first one is red, what's the probability that the second one is also red? And that's not what is being asked here. The question says, given one of the marbles is red. So we've ignored, let me just get my highlighter, we've ignored this one here and this one here and only looked at this. Now maybe you remember back when you first learned this, that conditional probability is about restricting the sample space. And that's what we're going to do here. We're going to say, out of these 3 pathways here that have 1 or more reds, what's the probability that it's this one here? So this is what we've been asked. Given we have 1 red, what's the probability that we have 2 reds? You can use the formula if you want to, but it's pretty easy. Out of all of the ones that have 1 red, or more than 1 red, what's the probability that we have 2 reds? And now it's fairly easy. 2 reds is here, 2/5 times 1/4. 1 red is this one plus this one plus this one, or 1 take away the thing you don't want, which is the 2 whites. And if you put that in your calculator, you end up with 1/7, which is B. Question 10. The diagram shows the graph y equals f of x. The point Q is a horizontal point of inflection. Let a of x equal the integral between 0 and x of f of t dt. How many points of inflection does the graph y equals a of x have? So we're being asked about the graph y equals a of x, and that is the antiderivative of y equals f of x. So we've been asked to sketch the antiderivative. All right, a quick look at this curve here. We can see it's got an even degree because it starts and ends together, if you like. A very quick way of figuring out what the degree might be is to have a look at the roots. So here we've got a single root. Here, at least a triple, could be to the power of 5, doesn't really matter. Single here, single here. So at the very least, we've got an x to the power of 6 graph here. The degree is 6. And when I integrate that, I'm going to get x to the power of 7. I'll get an odd degree. All right, we're going to look at each of these because they're all going to turn into turning points. when we integrate them. Right, let me rub that out. Okay, so let's look at this one first. So 0 here, we have positive through 0 to negative. And when we look at the antiderivative of that, that means increasing, flat or 0, stationary, decreasing. That's the same here as well. Going positive through 0 to negative, increasing, flat, decreasing. This one here, we're going from negative through 0 to positive. So decreasing, 0, flat, increasing. Now what about Q? Well, at the very least, this is an x to the cube. When I integrate it, I get x to the power of 4. And it's negative through 0 to positive, so decreasing. It will have a flatter bottom, and then it'll start to increase. All right, let's see if we can draw this. We have a maximum, a minimum with a flatter bottom, a maximum, and then a minimum. And we have an odd degree. Let's just get rid of some of this red so you can see what's going on, and then we will count the points of inflection. So we're going from concave down to concave up. There's one in there. From concave up to concave down. There's one there. From concave down to concave up. There's one there, and then we're off to infinity. There are 3 points of inflection. The answer is B. Okay, that's it. In our next video, we're going to look at questions 11 through to 22.